All right. Okay, so this is day 31, single replacement reaction practice. Oops. All right. So hopefully on the day 30, if you haven't yet, make sure you go through and check the answers on that with the answer key to make sure you know what you're doing. All right. So in single replacement reactions, you're going to use this activity series. Okay. And remember, if the metal is higher on this list, it's a stronger metal, it's more active, it's more reactive, it's more likely to kick out the other one, okay? The ones that are lower on the list are less reactive, they're weaker, they're less likely to kick out the strong ones, okay? All right, so single replacement, remember, is in some kind of the form like A plus BC, okay? A and B are going to switch places, and then you get B plus AC. Okay, so this is a single replacement reaction, right? These metals are going to switch spots, all right? The preferred place is in the compound, okay, is in the compound, okay? So the stronger metal will end up in the compound. Stronger metal in compound, all right? So they want to be coupled up, right? So the stronger one is going to end up being in the compound, all right? All right, so the first thing you have to do is decide if a reaction is going to occur. Okay, so we need to look at the metals, or sometimes hydrogen counts, right? It's not a metal, but it's still a positive ion, okay? So here we're going to compare aluminum and hydrogen, all right? This SO4 you should recognize as a polyatomic from your pink sheet on the back. So aluminum and hydrogen, so you're going to look at the list, okay? Here's hydrogen, and way up here is aluminum. Okay, so aluminum is the stronger metal, so aluminum is going to kick hydrogen out of the compound. All right, so when you get that, okay, then the hydrogen's going to end up alone, okay? But hydrogen, remember, is diatomic if it's by itself, okay? So hydrogen, always diatomic when alone. Okay, so you have to remember that, okay? All right, so it's going to be hydrogen plus, and then you're going to have the compound, all right? So I gave you this little cheat sheet down here, so you might want to write your ions. So your aluminum metal is going to become an ion, okay? And then your SO4 is a -2. You're looking on the back of your pink sheet for that. All right, so if this is a +3 and a -2, their least common multiple is 6. So this is going to be Al2 SO4 3. Okay, because I need 3 of these to make a -6, 2 of these to make a +6. All right, so then here's going to be Al2 SO4 3, and then that's going to be aqueous. Okay, that other compound is always going to be aqueous. All right, after we finish this, then we need to go ahead and balance. All right, so just do this in whatever way seems to work for you. All right, I would keep the polyatomic sort of as one thing. Okay, so here I have 1 SO4. Here I have 3, so I'm going to go ahead and try a 3 here. Okay, so that balances my SO4s. My hydrogens, right, I have 3 H2s here, so I'm going to need a 3 here. Okay, and if I have a 1 here, that gives me 2 aluminums, so I'm going to need a 2 here. Okay, all right, so when I draw this, I'm going to have 2 aluminums. Okay, and then plus 3 H2SO4, so I'm going to have an H2, H2, and then SO4, so I'm going to have an S, all right, and then 4 O's. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, okay? So I have 3 H2SO4s, and that's going to make 3 H2s, which I think I used the purple for that. So I'm going to have 3 H2s, make sure they look separated, okay? And then an Al2 with 3 SO4s. Okay, so I'm going to have those 2 aluminums, okay? And then I'm going to have 3 of these SO4s. So I'm going to have 1, 2, 3. Oops, I think that was the wrong color. And and then I used orange for the oxygen. So SO4, SO4, SO4. Okay, and that's all one together. Okay, so I have 2 of these, 3 of these, 3 of these, and 1 of these. Okay, for my word equation, okay, I'm going to have 2 moles of aluminum. Okay, I'm probably going to say solid aluminum. Reacts with 3 moles of, now I have to name this, okay, H2SO4, so we're going to just go ahead and call this hydrogen sulfate, okay. I could call it hydrosulfuric acid or sulfuric acid, but, you know, whatever's fine. Oops, and I forgot to say this. Let's say aqueous, okay, to create 3 moles of hydrogen gas and 1 mole of aqueous aluminum sulfate. Okay. All right, that's my word equation. Okay. All right, number 2, this one has a little trick to it, so I want to make sure to show this to you. Okay. When you see H2O, right, we want to think of this as a cation and an anion. Okay, so every time in these that you see an H2O, you want to think of it like a positive H and a negative OH, right? A hydrogen and a hydroxide. Okay, so that's how you want to think of water, because that's going to make it clearer who is switching places with who. Okay, so that's really important. So anytime you see water, you need to make sure to break it up like this, or you're going to end up getting it wrong. Okay, all right, so first of all, I need to see if the reaction's even going to happen. So I have calcium and hydrogen, right, because that's going to be my positive ion. So let's look at the activity series. Okay, calcium is way up here, hydrogen's down here, so that's definitely going to react. Okay, so the calcium and the hydrogen are going to switch places. So the hydrogen's going to end up alone. Okay, remember it has to be diatomic just like last time. Okay, and then the calcium became an ion, so that was a solid, became a calcium plus 2 ion. Remember, I'm looking at the periodic table. And then my negative ion is going to be an OH negative 1. All right, so that's tricky with the water, so make sure you break it up like that. Okay, so then I'm going to write the compound CaOH2, right, because 2 OHs at negative 1 and 1 calcium. All right, so plus CaOH2, and that's going to be aqueous. All right, okay, so let's go ahead and balance it. So again, you want to think of balancing with an HOH. All right, so I have 2 H2s and I have 2 OHs, right? So really, in effect, I need 2 of this, right? Because I'm going to have 2 H's for the gas and 2 OHs in the compound. All right, so it's a little easier if you think of it like that. So that's going to be a 2. Okay, that's probably going to be a 1. So that's a 1. Okay, and then I have 2, and then this is going to be a 1, right? So this is where it gets a little bit confusing, because you want to think of it like this, right? So I already took into account that I have 2 H's here. Okay, so I only need 2 here, because the other H was part of this OH. All right, so see, this has 4 total hydrogens, and I have 2 here, and I also have 2 here. Okay, so just be careful with that. Okay, all right, particle diagram, I'm going to have 1 calcium. All right, and then over here, I'm going to have 1 calcium. All right, and then I'm going to have an H, and then an H2 over here, and then an OH2, right? Then I'm going to have, let's see. Okay, so here in the water, I have 2 H's, okay? And then I'm going to have 2 OHs. So I'm going to end up basically here having these 2 waters. All right, so that's an H2O, that's an H2O. Okay, and this is going to be an OH and an OH. All right, so I have 1 calcium, 4 red hydrogens, 2 purple oxygens, 2 purple oxygens. All right, so word equation, I have 1 mole of solid calcium reacts, with 2 moles of, and just call this water. I see you guys are writing all kind of random stuff for water. I don't know what's going on with that. Okay, 2 moles of water, okay, to create 1 mole of hydrogen gas. Okay, oh, I guess I should have said liquid water. 1 mole of hydrogen gas and 1 mole of calcium hydroxide. Okay, so if you're not good at naming these, you need to go back and practice the naming. I think I put some videos for that. Okay, all right, so the main takeaways from this, again, don't forget your hydrogen is diatomic, okay, and then you have to split up the water into an HOH so that it's a little bit easier. Otherwise, it's going to be a little bit confusing. All right. Okay, make sure you do the rest first. Do it yourself before you look at the answer key. Don't just copy the answer key because you're not going to know how to do it. Okay, please don't do that. All right, bye.